We are live. Okay, so here we go. So today, again, we want to talk about max, min, story problems. There she is, Miss Brixie. Just in time for related rates. Some good stuff.
Just in time for what?
So think about it. This is a cool problem. This is a real problem. So because you're smart. So if the cone's leaking water, the height of the water drops like this. Watch my hand. It drops like this.
Yes.
So it's not a constant rate.
Correct.
So somebody smart has to be able to say it's dropping at however many inches per second, or it's dropping at this many inches per second. And I got all the smart kids here that are going to show you how this works.
How do you measure that?
Takes calculus.
Oh, son of a God.
You got to be able to take a derivative.
Good save. Thank you.
So here we go. Water flows into a conical tank. So it's just going the opposite. But you know, as water flows in initially, it's just going to feel like this. I mean, it's empty. It's going to go right. When you pour it in, it's going to go. And this slows down, but it's still going up. You guys agree? Okay. So water flows into a conical tank, 100 centimeters wide. So let me put my 100 here. And 250 centimeters deep, right? That's the shape of the cone. And then the water has the same shape. You agree with that?
Yeah.
Except for the water's not really 250 or 100, right? Because the water's going up. So it says it's coming in at a rate, so its volume is coming at a rate as 40 centimeters cubed per second. You just came and learned some math, didn't you? So it's like a garden hose. It's a constant rate. Does that make sense? You turn on the garden hose, and it's coming in at about 40 centimeters cubed per second. So, right? It's a constant rate, but it's filling up like this. Got it visually? Okay, now it says, find the volume of water as a function of height. So V of H. That's what I want to find.
So it's how much volume is coming in at a particular height?
Yes, so if I asked you, what's the volume at, say, 10 centimeters, or what's the volume at 30 centimeters, you could plug it in my equation. Snap.
And the volume would be different.
Yeah, totally right. Yeah. So now, what do I see? Well, I'm going to need to know something about volume. You guys agree? So what do you know about volume of a cone? Okay, well, Lauren, this is where, being Mr. Davies helps because, I remember all these formulas, right? So pi r squared h divided by 3 is the volume of a cone. It's 1/3 of a cylinder. Isn't that crazy? It's 1/3. You'd think it'd be half a cylinder, wouldn't you? It's 1/3 of a cylinder.
It's triangles. Just the triangles.
Yes, that's exactly right. Nice job, Kai. You always come up with a good answer. So what do we know? We know this 40 can go right here, right? But we have too many variables, right? We want a V of H. Oh, we can do V of H on this one, right? Volume with respect to height, right? Oh, we'll get time in here in a second, okay? No, we do have, forgot my T, 40T. I'm bad. I got distracted by Brixie. 40T. Okay, there we go. All right. So I've got too many variables. So I need to somehow come up with something regarding the radius. Okay, I've got too many variables. I've got T, R, and H. I want V of H, all right? So let's look at the height. Let's go back to similar triangles. Okay. So what we have is a similar triangle that is 50 by 250 for the cone. This is the cone. And the water, oh, I need blue to make it look really good. So I got a blue pen. The water going in is changing, but the height of the water goes to the height of the cone as the radius of the water goes to the radius of the cone. So we learned about similar triangles in geometry. It's the exact same shape. Ready? Exact same shape. The shape of the cone and the shape of the water are the same. Agree with that? The reason I want to do that is because what I want to do is kick out the r and do things in terms of h. So I'm going to multiply this up by 50. I'm going to have then 50h over 250 equals r, and then I'll just simplify that, right? I'll make that h over, what, 50 probably, right? 250? Yeah, 50 divided by 250. What's that? 1/5, or h over 5 equals r. And then I can substitute that in for my r. And I'm going to rewrite this whole equation as 40t equals pi h over 5 squared h divided by 3. Okay? I need to simplify that. I really do. That's going to be an h squared over 25. Okay with that? So that's a 40t equals pi times h squared over 25 h over 3. Oh, that's pretty ugly too. I need to simplify that. Okay? And I'm going to show this on the board because I want to be able to erase it. You'll see it in a second. I'm just going to do this really fast. Okay, just simple, basic, 6th grade math. Okay, invert multiply, right?
Yeah.
So it's going to be h squared over 75, so I'm going to put 75 down here. You okay with that? Okay, we're just going to do that because I'm multiplying it 75. Okay, so this 25 comes down here, multiplies by 3. Okay, that's why I've got to go back to 6th grade math. Okay, so I'm going to do that. And I'm going to make it an h cubed, okay? So then I'm going to have 40t equals pi h cubed over 75, right? Now, what do I want? V of h. Okay, so at what time? So now let's solve for h. So I can plug in any time and have it, okay? So if I solve for h, I'll multiply up the 75. 40 times 75 is 3,000. T equals pi h cubed. I'll divide by pi, right? Okay, and I'll cube root it. Times t over pi equals h of t. So at any time, right? Now, how am I doing? Am I doing okay? At what time will the tank be full? All right, well, what's the height of the tank? So if I put 250 in for height, and let's put it in an easy spot to put it into, right? If I put the 250 in for height, let's see, which one do I want to put it into? Height right here, 250 for height here. I can get the time, okay? That's probably the easiest one to plug it into. Okay, so if I put the 250 in here for height, I'm going to have 40t. I'm squished in here, aren't I? Pi times my 250 over 5 squared times my 250 divided by 3. Okay. I will wait for you, okay? I'll wait for you. And I'm going to need my calculator to do this. right, let me do this bit by bit. Okay, pi times 250 squared times 250. I'm going to divide that by 75, right? And I'm going to divide that by 40, okay? I sure will. I sure will. And I divide it by 40, okay? So I needed an equation that had height and time in it. This one does. This one solves for h. And I could have put it here. It might have been easier to put it here. Why didn't I put it there? I don't know. I'm going to put it here. It might make it easier.
Yeah.
Might make it a lot easier. Let's just do this here, okay? So the height's 250. I'll do it over here. I have cube root 3000 t over pi equals my 250, right? Cube it. You have a calculator, Andy?
Yes.
Cube it. What'd you get if I cube that?
Cube 250.
Oh, I can just leave it as 250 cubed, right? Divide by
15,625,000.
okay, multiply that pi by pi, right?
Okay. $49 million.
Okay, and then divide that by 3,000. Give me an answer. Hopefully it's that answer right there.
It is
What do you know?
60,000.
All right, and that's in terms, is that easier to do it that way, Ellie?
Yeah.
Yeah, a lot easier, right? And that's
Less
in terms.
steps.
Yeah, less steps. And that's in terms of seconds, I think. So if you want to divide that by 60 pi, gives you minutes, and then divide by 60 again, we'll get hours, right?
272 minutes. 4.5 hours.
4.5 hours to fill that tank. Big tank, huh?
Yeah. It's a big cylinder.
Yeah, it is. 16,362 seconds. Okay, turn the page. Okay, ready? Okay, now, example 2. Oh man, this stuff's making your brain hurt,
Yeah,
isn't
you're
it?
gonna do
This
it
makes your brain
again.
hurt.
I'm so glad we get to do it again.
Okay,
I love doing this.
now, so think about this real quickly. So everything I'm telling you makes sense. It's the math that's hard. You guys agree?
Yes.
It all makes sense. I mean, even that last problem made sense, right? So think about this. I got a rectangle. Think about like a cursor. Like you got a cursor. If my cursor
Yes, I
was
have a curse.
right here, this would be my rectangle. You with me? We're just going to move this point up and down, okay? So here's my point at xy. If I move it, it makes this rectangle, right? If I move this point up to here, it makes this rectangle, right? Kind of with me? If I move this point right here, then I'd have this rectangle, right? So this is some point, any point, that what we want to do is maximize its perimeter, okay? But it could be anywhere on this curve. Well, let's take a look at a rectangle. I know rectangle is, you know, that plus that plus that plus that, correct? So let's start making my rectangle. Okay, so I know that this width is x. It's whatever the x value is, right? You guys agree? Which means this has to be x also. Whatever the x value is, that width is x. That was, and yeah, guess what? That would also be x. That would be x because it's a 16 minus x squared, right? The height of this rectangle is whatever the y value is, right? Well, I don't know what it is. Just call it y. So regardless of where that point is, the perimeter is always going to be 4x plus 2y. You see it? So the perimeter is always going to be 4x plus 2y. All right, now, we know that it intersects at negative 4, 0, and at 4, 0, right? So the rectangle, as far as the domain can't be any bigger than 4, but no less than 0. Does that make sense? I mean, if this is all the way to 4, you get a flat rectangle. If this is all the way to 0, you get a tall rectangle. So the domain has got to be between 0 and 4, okay? Or set notation, less than x, less than 4, same, okay? Now, if we want to maximize the perimeter, we've got too many variables, right? So what I really should do is express the perimeter as a function of x. So I want p of x plus, well, let's get rid of y. Well, to get rid of y is easy. This one's much easier than the problem we just did. Do you see something for y? Of course you do. I circled it. Right? So the value of y is equal to 16 minus x squared, right? Well, and I can simplify this to a 4x plus a 32 minus a 2x squared, right? We could graph it, or we could use our negative b over 2a. Yes? Yes, sorry, Ellie. Yeah. So I'll wait for you, okay? So if we want to maximize it, and I'll let you catch up, we could graph it. And you guys like graphing it, don't you? Right? But negative b over 2a is super easy, okay? Because it's a parabola, so I can use the negative b over 2a. So I'm going to use my negative b over 2a. If you want to graph it on Desmos, you can. So I'm going to go negative 4 over a 2 times a negative 2, which is 1. Okay, what does it tell me? It tells me that this point right here has to be at 1 something. Okay, so my x value is x equals 1, right? And what's my corresponding y value? Well, that's easy too. What's my corresponding y value?
Yeah.
Right, put it right there.
Just put 1 on that.
Y equals 16 minus 1 squared, which is 15, okay? So now,
Okay.
all right, so my rectangle really looks like this. 16, 16, 2, and 2. Where did I get the 2 from? X and X, right? So what's my maximum perimeter? 32 plus 4 is 36, right?
Why is the y value less 16?
Oh, it's 15, because I made a mistake. I made a mistake. Ellie, thank you. 34. Because I'm bound to make at least one mistake every day. I am so sorry about that. I do. But Ellie, I appreciate you a lot. You know that.